This is the construction step of the NodeRAG. As you can see here, the basic idea is that you extract the relationships from those texts. And you can use any kind of graph construction techniques, but I think most of the time you just feed in LLMs and ask it to retrieve relevant tuples or relevant relationships. But as you can see already here, there's always a way that you will mess up something or make a mistake. That's why the original text also comes very important. What they do is they would identify some important entities based on the graph connectivity. For example, an entity that has been mentioned a lot of times in different documents, or another entity that has been a connecting entity of two communities. That's the only way that bridges one document from another document. So those are the important entities that maybe you want to pay attention to. They would use those nodes as the source node to identify different communities. On top of those communities, similar to GraphRAG, they produce some kind of summarization of those communities and so on. And later on, what happens is that at the last step, based on those extracted semantic community or extracted node, they would identify what are the texts that I mentioned a particular node. They add the text as one part of the graph. The text becomes one node or one type of node in the graph. And later on, they can separate the node into different types. Some node that you can produce an embedding on top of it, for example, the text or the attributes of a particular entity, or something that maybe you don't want to produce embedding because it's very short. And you can see here, when you have a query and you're trying to do a retrieval, first you can match longer text, for example, the text node or attribute node with embedding. You identify nodes on the graph, or you can match other types of node with just simple exact match. Normally, those steps will give you a bunch of nodes that has been identified in the graph. But later on, we still want to use the structure information. So you can expand the NodeRAG, expand all those extracted nodes to form a subgraph from the knowledge graph. But at the end of the day, you cannot really feed this graph into the LLM because for this query, you want to answer a question or produce a summary and so on. So what they do is they use personalized page rank, trying to find the important node on the subgraph and only use those important nodes as the retrieval results. And later on, once you have all those nodes that you have extracted, the rest will be easy. You just feed in those nodes as the context to the LLMs to answer the question. You can say this approach actually outperforms both GraphRAG and LightRAG because, as you can see here, it has the original text. So it not only have entities and relations, but the original text information is very important and is preserved in this process. But you can see here that one problem with all those RAG approach is that it's based on a very local community. So you identify some node and you expand maybe one or two hops. But the problem is that what if you have a fact that is not trivial? Maybe it's very long. On the graph, you have to travel a lot of different steps in order to derive the fact. Like one example would be a person's friend, I don't know, nephew, something like this. To answer questions like this, you have to travel this social network relationship several hops, identify the person, find the friend of the particular person, the friend of the friend, and then maybe the nephew of a particular friend. So those are the longer chance of reasoning that you have to encounter.